Good morning. I'm Dr. Mark Reinsel. I have a PhD in chemical engineering, specializing in biofilm engineering from Montana State University in Bozeman. I'm here at the Floating Island Research Center near Shepherd, Montana. I've been working as a consultant for Floating Island International for 4 years now. In a lot of our waterways in the U.S. and throughout the world, there's a battle going on right now. These high nutrient waters are a perfect growing area for algae. And unfortunately, algae is often winning that battle, creating dead zones through these high nutrient levels. What we want to do with floating islands is help other biological processes, biofilms, win that battle against algae. We want to provide surface area. We want to provide circulation so that periphyton microbes into a biofilm can take up those nutrients rather than algae taking up the nutrients, hurting our fisheries, reducing our dissolved oxygen concentrations, creating a dead waterway. We know that floating islands are a unique method for helping us win that battle. Why is algae winning the battle in high nutrient waters? Well, the answer is algae is a very simple life form. All it needs is water and sunlight and a little bit of nutrients. Biofilm microbes are a much more powerful natural force. However, to be effective, they need a lot of surface area and they need circulation. And what we're trying to do with BioHaven Floating Islands is provide that circulation and surface area in a natural setting, biomimicking natural floating islands, to help us remove nutrients and win that battle against algae. I've been designing biofilm reactors for treating water for almost 20 years now. The BioHaven Floating Islands that have been developed here at the Shepherd Research Center are simply another manifestation of these biofilm reactors. We've put them in place in various settings. We found that all we need to do is supply an underwater surface in the form of this matrix that the biofilm will grow on, possibly feed them nutrients they may be lacking, and they'll grow anywhere through the winter, through wind, rain, storms, high elevation, cold climates. The biofilm, once they're in a bacteria, are very resilient. It's interesting to see the beautiful floating islands that have been developed at the Shepherd Research Center and elsewhere. The first thing you notice about them is the greenery, the flowering, the plants that are growing, and at first glimpse you would think that's where all the nutrient uptake and water quality enhancements coming from. However, as a biofilm expert, I know that most of the efficacy, about 80% of the nutrient removal, is happening behind the scenes, underwater. It's microbes that are growing on the island matrix and the roots that are doing the bulk of the work. They're transforming things like BOD, nitrogen, phosphorus, TSS, and removing those from the water. And that's the beauty of the system. We're using natural bacteria, natural microbes, on an introduced substratum matrix to improve our water quality. This started out as eutrophied, low visibility water. The water clarity was as low as 14 inches. Through putting these floating islands in, BioHavens and Leviathans, increasing the surface area available to microbes in the lake, we've increased that Secchi depth to as much as 19 feet by removing the nutrients and the total suspended solids. One example that's come about because of that increased water clarity is kingfishers. Now, I grew up in North Idaho, identifying, loving to watch kingfishers, water ouzels, and other birds like that I knew only grew in very pristine waters. And we're seeing those now in Fish Fry Lake. The kingfishers can look down in this clear water, see the perch and other fish that are thriving here, and they're just another part of this evolving ecosystem. We think we're on the upward spiral. We think the water quality can improve even more. We're continuing to improve the fish productivity, the bird productivity, and it's becoming a complete ecosystem